Good evening, everyone. Hello. Everyone who's still standing up, there's still some seats at the front, there's some seats in the back, or there's some bar stools, and maybe we'll need to make it a little bit more cozy and squeeze up a little bit. Cool. So, welcome everyone to the sixth Apache Beam meetup. There's plenty of people, which makes me very happy. Um, So I'm Matthias. I've been running the Beam Meetup for 18 months now, and it's good that we've seen the community grow this much. So to recap why we are here, is to share our experiences and enthusiasm for technology, and especially Apache Beam. Of course, we want to learn from each other and from the experts who will be taking the stage later on, and we want to make sure people get inspired to actually go out and do something with Beam. And in the end, we want to, of course, build a community where everybody feels at home. And before we kick off, I want to say thank you, because without the help of some people here, this wouldn't be happening. And first of all, we have Revolut, the amazing people who have provided the space. And especially, I want to give a shout out to Andrew, Bulat, and Dime, who have been helping making this happen. Furthermore, we also have some people in the room, I think, from Datatonic. Datatonic runs big data and cloud consultancy, and I also want to give a shout out because they have been helped setting up the meeting and they sponsor it. And lastly, we have David from Google, who has been kindly providing the food and the drinks you're having. So make sure you talk to him. So a little update from community before we kick off. So if you want to talk about Beam online, you can use the Apache Beam London hashtag. If you want to stay in the loop on a daily basis, you can sign up to the mailing list or join the conversation on Slack. We also have a YouTube channel on which this will be uploaded later on. But there is also plenty of materials you already can check out from previous meetups and conferences. And if you want to give us feedback or tell or make yourself known as maybe a potential speaker, feel free to check out the survey. I will be posting these slides to the meetup page later on as well. So Beam has been doing very well on a technical basis in 2019. For example, Beam was in the top 3 most committed projects in the Apache Beam Software Foundation, in the Apache Software Foundation. And as you can see, it's been very healthy. Looking at the GitHub commits, we also been awarded the Technology of the Year 2019 by InfoWorld, and in 2019 we also had 2 new releases, 2.10.0 and 2.11.0, including lots of new IOs, Python 3 support, and improvements to the Flink runner. And community-wise, it's also going very well. We've doubled the size of the London meetup, and as you can see, this is materialized tonight. And there's also more meetups popping up around the world. In San Francisco, we had a great first edition. Stockholm is happening, Paris, Toronto, etc. So that's really nice. And as you might know, we'll also have a Beam Summit in Europe later on this year. More specifically, June 19 and 20 in Berlin. So if you want to know more about this, feel free to check out the beamsummit.org website and sign up to the mailing list. But I won't be keeping you from the actual material talks you're coming for tonight. And our first speaker is Dimitri, who's a data scientist at Revolut. I know they're hiring as well, so don't hesitate to talk to him afterwards. But he'll be talking about tonight is fraud detection. Afterwards, we'll be learning about portability, and that will be brought by Robert from Google. So I'm happy to invite Dimitri to the stage now. Thank you very much. So there's a slight technical issue. We'll be back shortly. Yeah, we'll be back in 5 minutes. Maybe enjoy some food and some drinks in the meanwhile. Thanks. So, people, we're back. Sorry about that. I'll give the stage to Dimitri now.
Hello, hello, everyone. Can you remember the time in your life when you made a big decision about something? When there was, when a light bulb came on for you in some way? When there was a turning point in your life? Who can remember a time like that? Big time that turned around everything for you. Cool. So, if you were with me on July 25th, 2015, you'd be enjoying the sun and the sound of waves on a beautiful sandy beach that you wouldn't expect to find here in the south of UK. I've just finished a 4-day kite surfing course, zero to hero, and I'm keen to continue doing kite surfing. So I come to a local kite surfing shop to purchase my first wetsuit. You do need one to spend 5 hours in a day in the local sea, even in summer. So I come to a guy at the till, I hand in my credit card, but I'm way too excited about my purchase to pay much attention to the fact that instead of inserting my card into the chip and pin device and asking me to enter my pin, the guy at the till just takes my card and starts entering my card details on his website. That's how I paid for my purchase. The following day, I get a phone call from my bank, and the lady on the phone asks me to confirm my recent purchases, like Amazon for £200, Netflix for £12, and I don't even watch Netflix. And of course, the bank returned me the money a couple of days later. But this feeling, the feeling as if someone gets into my pocket and steals money from me, haunted me for a few weeks while I was thinking, how could I have prevented this? We're now in April 2016. It's the year when the world started to talk louder about artificial intelligence and machine learning. It was the year when DeepMind's AlphaGo beat Lee Sedol, the world champion in the game of Go, which is considered to be one of the most difficult problems for AI to tackle. It's the year when Google launched their machine learning platform on Google Cloud. I'm excited by the opportunities that artificial intelligence opens up. So I sign up to a number of courses on Coursera and Udacity, and to my surprise, 18 months later, I finished them all. And most probably, it's due to this stick note that I attached to my saying, I want to change the world and improve people's lives through the application of AI algorithms. Whatever works, guys, right? Whatever works for you. We're now in July 2017. I'm looking for problems to solve with the newly acquired knowledge when I discover Revolut. And I want to be part of this something new, something meaningful, you know? And I think that changing the world of banking is something that I really want to be part of. So on a Skype interview with Nick asks me if I would like to help Revolut prevent fraud. And I, remembering my fraud experience a couple of years earlier, I immediately say yes. I see this as a chance to get revenge, to show fraudsters that we can protect ourselves. Now picture this. It's October 2017. Revolut is a 2-year-old startup. The only database in place is the transactional Postgres. Business intelligence queries that run against this database are already incredibly slow. And I face the challenge of analyzing millions of transactions, trying to identify which one are fraudulent or not. What would you do in this situation? 9 months after joining Revolut, I built Sherlock. What is Sherlock? Sherlock is a machine learning-based fraud detective that continuously monitors your transactions, and when it notices a suspicious one, it declines the transaction, freezes your card, and sends you a push notification asking you to confirm whether it was you or not. Just like that. Sorry. Now, it took me a while to understand how exactly I built Sherlock, but I decided to put my experience into a system which I call the data-driven development framework. Why data-driven? Well, because I think that the quality of the solution of any business problem boils down to the quality of the data that you have available. And thus, obtaining the right data is at the core of this framework, which consists of 5 elements: define, discover, design, develop, and deploy. Now, I wish I had more time to go in depth into each of these elements, but in order to give you an idea of how Apache Beam fits into it, let's walk quickly through this framework. So we start with defining a problem. We data scientists and engineers, we love playing around with various new software, but I keep reminding myself that ultimately technology should serve the business, not the other way around. And that's why we start with finding the problem that we want to tackle. So in my case, I wanted to predict whether any given incoming transaction is fraudulent or not. The second thing that we need to define is the right metrics. Now, why is it important? Well, the thing is that if you pick the right metrics, you are prone to committing so-called type 3 errors. These are errors for which you get the right answers for the wrong questions. In our case, since we are solving the binary classification problem, we pick the metrics such as precision, recall, and false positive rate. But since we are dealing with fraud, we ask ourselves, are these really the best metrics? And I'll show sometime later what other metrics we are using. The third item that you need to define over here is the right talent that you need in order to solve this particular problem. And in our case, we of course needed some project management, data wrangling, and data analysis. And of course, as it often happens in startups, one person wears multiple hats. But of course, I couldn't get by without the help of our backend engineers, mobile engineers, designers, and of course our fabulous data team over there. The next item in this framework that I want to talk about is about discovery. So what I mean by discover? Well, firstly, we need to set on to discover labels. What are labels? Labels are categories of your data that someone in the past assigned to your data, so that you could predict these categories for any new incoming data. And in our case, we are solving the fraud detection problem with supervised machine learning. Hello? Yeah, sorry. With supervised machine learning. And that's why I needed to have our transactions labeled as fraudulent or not. The next item that we look into in this section is data. And over here, I like asking myself a question. If I had any piece of information, however unbelievable, to make the perfect decision, what would it be? And with this thinking, we approach this problem by ensuring that we have the right data quality, because in the end, garbage in, garbage out, as we know. And we do some data analysis on a small subset of users. And the next item we need to pay attention to is to visualize our data and do hypothesis testing to help us understand whether the data that we discovered actually makes sense. Now, the next item is design. And over here, we design the architecture of our solution. And in our case, as I will show later, we have the online processing along with the nightly batch. Secondly, we need to take into account user experience, because we want to ask users for the feedback for any transactions that Sherlock deems fraudulent. Finally, the third item is we need to consider how we integrate this service into the existing backend system. And in our case, we built it as a standalone transaction monitoring service. The next item that we look into is the development. And here we need to take into account the language that we're going to use. In our case, we used Python in the full data processing stack. I know that some companies pick one language for batch processing and another language for online processing. I believe such approach is prone to having inconsistencies in these two code bases. So after some discussions, we decided to stick to Python because it's a go-to language in the data community. The next thing that we work on is what's called feature engineering. We need to create features that we will feed to our algorithms. And that's where Apache Beam comes into play. Finally, we need to pick the right algorithm to solve our problem. And to solve fraud problem, we decided to use gradient boosting on decision trees. Finally, we look into deploy solution. And here we look into how we orchestrate, for example, retraining of our machine learning models. And for this, we are using Google Cloud Composer, which is a managed Apache Airflow to schedule these kind of tasks. We then look into the resilience requirements. And as you can imagine, you would like to be protected 24/7. So Sherlock is a mission-critical application. And I believe we managed to achieve high availability by using such services as Google App Engine and Couchbase for the database, as we will see later. Finally, for monitoring, we are using Stackdriver Alerts and Kibana. Now, in order to give you an idea of the problem that I'm tackling, let's look into this example. So let's imagine we have a user who went to India, and there she took a taxi where she paid for the sorry for which she paid using her Mac stripe, which is the black stripe at the back of your card. A couple of days later, she comes back to London and buys something. Oh, sorry, and buys something in the airport cafe using her using chip and pin. I would highly recommend, whenever you travel, whenever you come to the new country, buy something at the local airport if it's possible, using either chip and pin on contactless. And that's how you help Sherlock determine the country where you are in. Now, a few days later, our user sees that someone withdraws money from her bank account. Now, how could this have happened? Well, apparently, the taxi driver over here, sorry, the taxi driver, besides charging her card, she made a copy of the information stored on this magnetic stripe, and he then went on to make a clone of her card, which he then either sold on the internet or just used himself to withdraw cash from an ATM in India. So why do I refer to India over here? Is because along with such countries as US, as Canada, Magstripe is highly popular in these countries. Now, if we were to predict fraud, for example, if we manage to catch fraudulent transactions over here, for example, this one, we could say that, or say this one, we could say that our recall rate is like 50%, which is not that bad. But as you can see, if Sherlock managed to catch the first instance of fraud, we could have saved much more money. And this is where such metrics as recall, which matters the percentage of caught fraud, might not be very accurate. So we might need either to give higher weights to our transactions, or, as I do in production, for me, recall is just the lower estimate of all the fraud that Sherlock managed to prevent. Now, here is the architecture of Sherlock, and as I said, it consists of two parts: the nightly batch and the online processing. Now, the nightly batch starts with nightly dump of data from the transactional Postgres into BigQuery. After that, this data is being used by a number of Dataflow jobs that generate user profiles that get dumped into Couchbase, and training data, which gets dumped into BigQuery. The training data is then used by Google Cloud ML with where we train CatBoost, which is the implementation of gradient boosting on decision trees. Whenever you go and make a transaction, for example, at Amazon or at Starbucks, our processing backend in under 50 milliseconds sends this transaction to Sherlock, which is the app running on Google Cloud App Engine. At this very moment, Sherlock goes into Couchbase to fetch your profile, and using pre-trained model, CatBoost makes the prediction for the given transaction. It then sends the response back to the processing backend, and the processing backend is what either allows the transaction to pass through or declines it and sends you a push notification. Now, as you can see, Apache Beam is at the heart of this solution. So why are we using Apache Beam? We are using Apache Beam for what's called feature engineering. So what are features? Let's look into this problem. So at first, we start with so-called stateless features. These are features that we get directly from the merchant's acquirer. So as we saw in the previous example, such features include, for example, merchant name, the currency of the transaction, the amount, the date, and so on. We do little pre-processing on these features. The other type of features that we couldn't generate without Apache Beam are so-called stateful features. The features, firstly, that are user-focused, which compare the value of the current transaction with your previous transactions. And what I mean by that is, whenever you make a purchase, say at Amazon, we compare by how much this purchase is different to your previous purchases, say at Amazon. And another type of features are merchant-focused features that compare the current transaction with all fraudulent and non-fraudulent transactions of the given merchant. For example, I'm asking a question by how much your current purchase is at Amazon is different to the average purchase that all our customers make at Amazon. Now, why would I use Apache Beam, right? So like as proper engineers, we need to analyze any other alternatives. Oh, sorry. Let's start with the problem that we are trying to solve. And the first problem we are trying to solve is to generate training data. What I mean here is that we need to generate features for our transactions and not take into account any transactions that happen after this transaction. So if I sort all my transactions in the chronological order, when I generate features for my transactions, I don't want to look into transactions that happen kind of in the future in relation to the current transaction. And the second problem that we want to solve is to be able to quickly generate user and merchant profiles so that every night we could regenerate these profiles to fix any errors that occurred during online processing. So both of these problems are are of the type that's called embarrassingly parallel problems. It means that they can be easily split by multiple independent tasks. So let's look at any alternatives that we could have used. And we start with, of course, good old SQL. Now, why are we not using SQL? Well, from my perspective, it's difficult to scale and difficult to debug features generated using such SQL code. We could have turned to Python multiprocessing, but in my point of view, it would result in lots of code that is specifically targeted at making our feature generation parallel. And of course, we could have used good old Apache Hadoop, Hive, Big, Spark for batch processing, Storm or Flink for streaming analytics. From my perspective, it requires setting up a cluster and managing it. And again, if you remember, in a startup world, we are all limited by resources. Secondly, if I picked this stack, it would require me learning all these technologies and frameworks. Now let's take a look at the pros and cons of Apache Beam, and we start with the well-known fact, I would say, that Apache Beam presents a unified model for batch and streaming. Therefore, I can use the same code for batch and online processing. Apache Beam allows me to focus on the transformations that I make with the data and not focus on how to make the code parallel. Finally, I see Apache Beam as the next evolutionary step in big data processing. Like in the beginning, there was Hadoop, and developers used Spark for batch processing, Storm for online processing. But then developers started to think how could we unify both online and batch processing into one framework? And this is how Apache Beam was born. That's how I tell this story to myself, I guess. And regarding the cons, well, Python support, to be honest, lags behind slightly Java, for example, in streaming. And that's why here at Revolut, we haven't come up with a use case to use Apache Beam in the streaming mode. And also, Python 3 is still not fully supported, and for some members of our team, this is a huge problem. I couldn't come up with the third option with the third negative aspect about Apache Beam. If you do know something, please let me know, but so far, pros wins, and That's why we have chosen Apache Beam. And this is the example, just to illustrate how elegant the code is, written in using Apache Beam framework. These funny operators, sorry, gosh, these ones, the pipeline operators, whenever I use them, I visualize how my data travels through a conveyor belt. And in these 20 lines is the whole logic of creating user profiles. As we can see, it starts with reading BigQuery, reading BigQuery table. We then create some time features and so on. We then map our transactions by wallets. We group by wallets. We clean up. We generate more features, and finally we dump everything into Couchbase. And that's it. Well, of course, there is lots of everything behind these classes, like process transaction FN or create MCC features FN. But in essence, these 20 lines of code represent the transformations that we do with our data to create user profiles. Now, why did we choose Google Cloud Dataflow? Dataflow is one of many available runners for Apache Beam. Other runners are, for example, the direct runner, which means you can run any Apache Beam script on your local computer. I love the idea of serverless computing. To me, it falls nicely into this paradigm of the sharing economy and on-demand resources. Think companies like Uber, Airbnb, or Borrow My Doggy, the service that allows you to borrow your neighbor's dog. In addition, Apache Beam automatically handles any data duplicates and retries on errors. Any duplicates might happen when you, as I understand, when you use streaming from PubSub. Next, I see running these jobs, running Apache Beam jobs on Google Cloud Dataflow is as highly cost effective. I use only the minimum required of servers, and I will illustrate this in one of the next slides. In addition, what I really love is that it allows developers to focus on, well, this is, yeah, sorry. So it allows developers to focus on the business logic rather on managing the infrastructure. And I think we all want to work on more meaningful tasks, right? Finally, what I really love is the Dataflow Shuffle service. Shuffle is the operation that is performed whenever you group by key, like in our case when we want to group transactions by wallets. Usually, shuffling is the bottleneck in such pipelines, because if you imagine processing millions of transactions across multiple clusters, whenever you want to group them, you would need to shuffle these transactions across different nodes that gather transactions by wallet. And Google Cloud, sorry, and Dataflow Shuffle service is what allows you to do with very cost effectively, I would say. And I will also illustrate it on the next slide. So, and also the great thing about Dataflow is that I can visualize that that code that you saw earlier in such a diagram. All these boxes represent some operations that I perform either on transactions or on users. On the right, you can see the diagram of the number of machines used throughout time. And as you can see how it goes up and down and use only the minimum number of virtual machines. The next diagram is also just one of the jobs that generates features for us, the features that Sherlock then uses to train its models. And as you can see also on the right, the diagram showing the number of virtual machines used throughout time. It's also like it peaks at 20 for about an hour, and then it just uses maybe one machine, like one or two machines. Besides these two jobs, we have 4 other data scientists who use Apache Beam running on Dataflow to generate features for their for other fraud models, and also for segmenting users to analyze their behavior and to split them into various categories to analyze their risk. Now, regarding the cost, what I also like about Dataflow is that it's transparent pricing. For example, to generate user profiles, one job costs us just $37. To generate merchant profiles costs us $130. And to generate the whole training data set for Sherlock cost us $260. Well, maybe you need to add like $5 for BigQuery costs, because that's where we store our data used by these Dataflow jobs. Now, what all this helps us achieve is to protect our users from fraudsters. And this is one of my most important and my favorite dashboards that I built using Canva app on, in Kibana. As you can see over here, so it's just a snapshot in time, and over here I track such things as the number of, as the number of fraud cases caught per hour, the number of, so the number of fraud cases caught in the last 24 hours, number of false positives. My goal is to make this unicorn completely pink. And my recall, so if you remember, I mentioned that recall might not be the best metric. I interpret this recall as the lower estimate of the percentage of fraud that Sherlock managed to prevent. But the most joyous part in this work is reading users' Twitter comments. For example, thank you, Revolut. Come on. Just doesn't listen to me. Thank you, Revolut app. Somehow my old card was compromised. You automatically stopped the fraudulent attempt to withdraw $500 somewhere in the USA and managed to send me a replacement card that arrived 36 hours after ordering. You see, for a bank, losing even tens of thousands of pounds per month might not be a big deal. But for a single user, losing $100 might be the difference between an unforgettable vacation and a vacation filled with anger and frustration. And that's why we keep working on pushing this frontier in the never-ending battle against fraudsters. And I believe that we are living in remarkable times when enormous computing power, data processing power, and the talent of world-class engineers is at our fingertips. And the only thing that limits us is our imagination. So I would like to finish with the following quote. It's also pinned as a sticky note to my wall by D. Hogg, the founder of Visa. It's no failure to fall short of realizing all that we might dream. The failure is to fall short of dreaming all that you might realize. So what will you come up with next? Thank you. Any questions? We have some prizes for great questions if you have one. Yes. Right. What other challenges? Um, well, I can honestly say that there were cases when I accidentally did something and that resulted in locking lots of transactions. And that's why I decided to set up Elasticsearch, where I stream my data as it happens, and I could show you a live dashboard where in real time I see not only how many transactions Sherlock blocks per minute, but also users' responses. And now whenever I deploy a new model, I kind of watch this graph and trying to see if everything is runs smoothly. But so far, we have fully automated this process, again, using Composer and Google Cloud Airflow. So now, every night, this whole process of retraining Sherlock happens automatically, and I just, every morning when I wake up, I immediately turn on my computer to watch the stats. So Oh, got it. Perfect. Yeah, absolutely. So, as I said, as you can imagine, I joined Revolut in October 2017. The number of transactions, well, I just don't even remember the number of transactions, but the number of users was around 1 million. The number of cards on which fraudulent transactions happened was around 2,000. So that's like, I think, zero point 0.1 basis point or so. And of course, I do remember kind of sitting over there and thinking what kind of machine learning I can apply over here. Um, but luckily, using some techniques like undersampling, so we just used, well, for now we use a random number of 1 million good transactions and all fraudulent transactions. And what really helped us is actually getting users' feedback, because now when I get users' feedback directly, I also use these transactions as my data points, as my label data points. And I also use transactions which happened on the card after that as fraudulent. So now I have well, I mean, I infer that the transactions that happened after the user logged their card as fraudulent, and now I have much more data samples. So again, it's I guess whenever just like a standard procedure, whenever you face a difficult problem, you just persevere, you figure out how to solve it, and you solve it eventually. Yeah. Any other questions? Right. Right. Great question. Yes. So in the very beginning, whenever I was analyzing users' transactions and coming up with any new features, I used purely Jupyter notebooks and plain Python code where I generated those features on a small subset of users and using Python multiprocessing over there. But when we came up with a solid set of features, we moved on to generating these features using Apache Beam. And the development of any new features went much more quicker because we now had like code written to generate these features. And whenever we, this process of feature engineering is the most difficult, but at the same time most interesting part in this work, because it's a very creative process, and I really like it. Sometimes I come up with new features in the shower. Um, yeah, so and it's it's easy to quickly integrate that new feature into Apache Beam script, quickly generate the training data and verify that it brings additional performance to the model. Does this answer your question? Or kind of what kind of data analysis, where we plot our data and see how they fit into normal distributions and all that stuff. We use hypothesis testing to verify that it kind of makes sense using these data elements. So I'm not sure why you are asking Airflow, because Airflow is the thing that we use for scheduling our jobs, right? So Airflow is kind of the advanced version of cron. I think what you meant Apache Beam and Dataflow, right? Or
Yeah, you've answered the question.
all right, cool.
So you have a fairly complicated pipeline, and so my question is first, how can you introduce briefly how do you do testing? And second is, have you ever encountered any performance challenge?
Performance challenge. Can you please pass the prize to the great question? Um, how do we test the data? So whenever I get back to analyzing if any new features will improve performance, I spin up, well, I used to spin up Jupyter notebooks on very powerful virtual machines with like 64 cores, 256 RAM and so on. And I generated the training data and the test data split by time. So what we are trying to prevent is the future fraud, and that's why my training data is split only by time. I trained Sherlock on a period of 1 year transactions, and I evaluate the model on the next 5 weeks. So that's how I test Sherlock's performance until some time ago. Recently, the number of users has started to grow rapidly. We now hit over 4 million users, and loading all this data into memory has become incredibly difficult and costly. So what I started to do now is actually using Apache Beam to apply the trained Sherlock model on the test dataset. So why I love running Apache Beam and Dataflow is the fact that in the setup file that I configure alongside with the job, I can pre-upload the trained model into the memory on each of the whatever number of virtual machines that I spin up. And then I simply read that data from BigQuery, and for every transaction in like massively parallel way, I make predictions for any given transaction. As a result, I can apply my model on pretty much infinite number of users and transactions to evaluate the real world performance of the model. And that's how we kind of currently operate mostly. Oh gosh, I'll have to walk a lot.
Hi, thanks. Hi, thanks for the talk.
Thanks for coming.
My question is, you showed how you use Apache Beam to do feature generation prior to training your model, but I'm interested in during inference time when you get raw data in, do you also use Apache Beam to do feature generation?
Great question. So you see, whenever you go to Starbucks, for example, and pay with your card using contactless method, or when you make a purchase at Amazon, you pretty much don't want to wait like a minute or maybe even like 15 seconds. I have to reply really fast. And now the 95th percentile is under 50 milliseconds. The 99th percentile is something like maybe 80 milliseconds. And the limit that I was given by our processing backend is 250 milliseconds. If Sherlock, which happens rarely due to some issues, if it takes longer than 250 milliseconds, the transaction simply goes through. And I do monitor like the number of unchecked transactions, and I have alerts on that. But fortunately, this happens like really rarely. And as to your question now, why I'm not using Apache Beam in that online prediction is again because I need to answer very fast. Sherlock is a well, right now it's a Flask app deployed on Google Cloud App Engine on like 5 nodes, each node running I think like four instances of Flask app, and inside each of these processes inside the Flask app, I pre-upload well, as of a week ago, 3 Sherlock models split across different entry methods, like one model for contactless, one model for chip and pin, another model for e-commerce transactions. And when I get a raw transaction from our processing backend, which consists maybe of like 10 data elements, again, like merchant name, the amount of the transaction, the currency. At this very moment, this Flask app goes into Couchbase, fetches your profile, generates features inside this Flask app, and creates such feature vector, which is then input to the model, which is, as I said, loaded to memory, makes the prediction, sends the response back. So I did want to use Google Cloud Dataflow streaming in some kind of way, but this was not the case. I feel that I wouldn't be able to answer under the given under the given time limits. But great question, thank you.
Hi, I have a question. I want to ask you, how do you do A/B testing on different models? If you have a new model you want to test, how do you do that in online fashion?
Um, A/B testing. Now, there is a lot of controversy in this A/B testing world. Um, to be honest with you, whenever I check that on my test data, the feature importance is significant and it results in increased precision recall or decreased false positive rate, I take the step to deploy the model into production and monitoring its performance. The difficulty about seeing the model's performance live is the fact that I get the feedback on false negatives, that is the fraudulent transactions that Sherlock missed, in a few days at least. You see, most users submit fraud claims in like 0 to 2 days after the transaction happened, but users have up to 120 days to report whether a transaction is fraudulent. So a straight answer to that is no, I don't do any A/B testing. I do testing on the test data, and then we see the result in production. Yeah. One more question, please.
Or not?
Or not?
Oh, there we go.
Maybe a quick one. Was there anything that you couldn't do through Beam, or you had to really work around in order to try and achieve the result you were trying to do?
Great question, and maybe even you could help me sort this out. You see, so yes, I made some mistakes, and I will mention which one exactly. I hit some limitations of Beam. At first, when I mentioned that I generate merchant profiles, you might think that I just take, for example, Sainsbury's, all their transactions, and then go like one by one to create features for each of such transactions. As you can imagine, even in one day, Sainsbury's process millions of transactions, and putting them into, so in the example of the code that you saw, the group by stage, the result of the group by stage is the key value, where the key is the user's wallet ID, and the value is the ordered list of transactions. So when I first tried to generate such profiles for merchants, I just kept increasing the virtual machine type until I decided to just go and use the most powerful machine that was available over there. Such profile generation ran for like 20 hours. As a result, the cost just jumped. And I do remember writing to Google saying, guys, can you give us some coupons for Dataflow? Unfortunately, they said no, and I just had to explain what I did and how I will never let that happen ever again. But regarding something like more serious limitations, like yes, so as I mentioned, I cannot fit as many transactions as I want into one key value pair, but that kind of makes sense. I was then thinking, all right, if I now have such, let's say 5 million of merchants, each with key value, and the value is a limited number of transactions, can I instead run kind of micro Apache Beam jobs for all these transactions? But I haven't come up with well, I'm not sure if it exactly made sense, but essentially what I wanted to parallelize is the processing of individual transactions within a single merchant. And that's what I didn't come up with how to do, and that's why right now, sorry? Windows. I believe when I started this, Windows were not supported in Python. I think that in the latest release of Apache Beam 2.11, I think both windowing and even eventing is supported in Python, but it's not well documented. So I had to go into Java. I also experimented with Java. My whole idea was to make everything flowing and streaming. And whenever I get a transaction, I would unfortunately I wouldn't be able to answer in the allotted time of 50 milliseconds. I feel that would be the case. You're very welcome to apply in there. So
Awesome, thanks, Dimitri. So our next speaker is Robert, but first a round of applause, please, for Dimitri. So maybe we'll wait 1 minute for people to grab some drinks and then take a seat again, and then we'll kick off with Robert. Can everybody take a seat again, and then we'll kick off with Robert? I'll run them once more. Everyone? Okay, everyone, shall we take a seat, and then Robert will kick off his next talk. Thank you.
Okay. So I'm Robert Bradshaw, and I work for Google on Apache Beam, and I'm going to be talking a little bit about the vision of portability and how we're actually making that possible. So, kind of to start out with, Beam's vision at the beginning was to provide a comprehensive framework that allows you to execute a pipeline on the engine of your choice and write it in the language of your choice. And this is kind of what started the Beam project as opposed to just Dataflow. Is we wanted to be able to have people develop their pipelines in a language they're comfortable in, using the libraries and the ecosystems they're comfortable with, and then have freedom to execute it on a variety of runners. So Spark, Flink, Dataflow, whatever. And so this is kind of a pictorial representation of Beam's vision. We have a whole bunch of languages that we support: Java, Scala, Python, Go, SQL, and then we have a whole bunch of runners. And you can kind of run these pipelines on these runners. And the problem is that, at least as of last year, this is kind of the reality. And you can see it's not very pretty. We have Java is actually very well supported. As was mentioned in the last talk, you can run Java on a bunch of these different pipelines. Scala kind of depends on Java, so it gets that for free. Python only ran on Cloud Dataflow. We hadn't hooked it up to PySpark or anything like that. Go was being newly developed, and Go didn't really have a target because kind of this choke point was Java objects. And so this was not where we were going to go. And we said, well, just trying to make all these lines here, that's not very sustainable. There's quadratic amount of work to connect N SDKs to M different runners. And so we said, well, we need a more viable solution than just trying to write connectors for everything. So we came up with the portability framework, and this is a language agnostic way of representing and then executing a Beam pipeline. So I'll go a little bit into kind of what this looks like. So right now, with the portability framework, this is as of earlier this year, we can now have Beam portable proto-representation of a pipeline, and all these languages can then compile down to that portable representation, and then we're porting runners over to run based on that portable representation. So right now we have Cloud Dataflow, Apache Flink, and Samza, new runner. And we have, there's actually a PR just got merged on GitHub on my plane ride over here. It was nice to see, that does some preliminary work for Apache Spark. And so this is kind of the direction we're going, is making everything go through these protos. And this is realizing the Beam vision. So you might ask, well, what's in it for me? I'm not a Beam developer yet, maybe. And well, what do I get from this? Well, the first thing you get is, of course, that means you can actually run, as mentioned, Python pipeline anywhere, not just on the runners that happen to support it at this point. But kind of along with it, you get some other things. So you get a configurable hermetic worker environment. You can get the ability to do multi-language pipelines. And finally, a lot of the new features, like especially the splittable do fun, is only going in on the portability model. So let's look at a couple of these advantages. So when you're using Beam, typically what you do is you're using Beam because you want to do a distributed workload, or at least you want to do a managed workload, in which case you write your code, and then you want to ship it off to some remote machine to actually execute your code. And where you ship it to this remote machine, lots of times how you configure that remote machine is very runner dependent, and it's also very runner constrained. For instance, if you want to use version X of Guava, and Flink decided to depend on version Y of Guava, all of a sudden you have two versions of that same library. You have the diamond dependency problem. You also have, well, what knobs does the runner expose to actually let me customize the environment that I want to execute my code in? And a lot of you, if you're using Java, one of the nice things about Java is it has this run anywhere promise. That is, if you ship everything in a giant jar that ships all your dependencies, this usually works for Java as long as you don't have any dependency conflicts. But especially in other languages, like for instance in Python, shipping everything and all your dependencies means you're trying to ship C libraries. You're trying to ship, compiled code. You're trying to ship random files that might exist on your computer. You might want to ship configuration files. You might want to ship data files. And this happens in Java too. And it becomes very difficult to say, okay, what do I want my worker to look like? And especially because typically you develop your pipeline locally, you test your pipeline locally, and then you have a very different environment when you're actually deploying. And this is a very uncomfortable situation where you say, I could have sworn I tested this. Everything works just great for me. And then you go to deploy it to production and it breaks because, you forgot to say, oh, by the way, I need this file to be on all my workers because it contains my config data. Or, oh, I don't have my authentication credentials, or something weird like that. So this is a very common situation when you go to deploy your pipelines. So one of the things that portability brings to us is the notion of an environment that is a core concept that you tie to your Beam pipeline. So every user operation, your parallel do operations, your maps, your filters, your combined operations, is tied to an environment. And typically that environment is just whatever the SDK is, but you can let it be any environment that you want. And this environment is specified typically as a Docker container. So this says you can put anything in that Docker container that you want. You can put dependencies in that Docker container. You can install C libraries that you shell out to. Kind of just, the sky's the limit about what you can put in that container. You can compile things ahead of time. One of the things with Java is you have to kind of do runtime installation of these things on every worker. Well, now you can compile it and configure it all ahead of time. The other thing is this environment is completely isolated from whatever your runner has. So if your runner is Flink and it has a whole bunch of dependencies and Java libraries built in, well, whatever you put into your Docker image is completely separate from whatever the Flink developers decided to put in theirs, or the Spark developers decided to put in theirs. The existing runtime way of saying, well, take my SDK and add these extra jars that are compiled is, of course, still supported. So, for instance, you don't have to rebuild your entire Docker environment when you edit your code and you recompile it. You still ship the jars that get put into this environment. But this is kind of the key fact of now you can use these environments locally to do your testing. So your local environment now matches your production environment, and you can debug your code locally on your computer. You can get it working, and then when you actually deploy it, you have high confidence that this is exactly the same environment as well as the exact same code that you are running and testing and developing against. Of course, we also have cheaper environments. Some of the environments we have is subprocess, where you don't want to spin up a whole Docker image. You just say, okay, spin up the worker as a subprocess. Spin up the worker as an embedded environment, meaning it's actually in process. And interestingly enough, the Python direct runner is just using the Fun API, this portability framework, and the environment spins up as, okay, this is just a little thread internally into my process rather than spinning up a separate worker. So this is kind of the advantage of Beam environments. It gives you this hermetic way of describing exactly what your execution environment is, as well as your code, such that when you deploy it, you know where your code is running. So the other big thing that we got from this is cross-language transforms. So now that we have portability, we have a language-agnostic way of representing your pipeline, and we have per user operation specification of the environment that it should be run in. And so suddenly we no longer have the constraint that operations need to have the same environment. So for instance, we can say, run part of our pipeline is in Java code, some of it's in Python code, some of it's in Go code. You can say, well, I want this portion of my pipeline to be Python 2, this portion Python 3. Here's a Java 11 chunk. Kind of mix and match as much as you want to get all these different things working together. And typically when you're writing a pipeline, lots of times you don't necessarily have more than one environment, but the big thing this opens up is libraries. So as it was noted, the Python SDK, it was released about 2 years after the Java SDK, and you could say it's probably about 2 years behind the Java SDK in terms of full-featured sets of everything that it supports. Well, now what we can do is we can use that huge suite of input-output operations that Java has, and we can just use those right from Python. Likewise, for instance, there's a big framework called TFX that is written in Python to do machine learning on Beam pipelines. And you can say, well, instead of having to port that to Java and keep it up to date, you can have your Java pipeline invoke those Python operations to get TensorFlow and then the whole TFX framework. You can use SQL as kind of a nascent thing that's coming up. Is there's SQL, the ability to embed SQL statements in your as operations. You can say, well, we can use that from Python and Go because we can just do cross-language stuff. And so this allows you to use kind of every time a new library is used, you no longer have to implement it for every single SDK. You're enriching the ecosystem as a whole. You're helping all the users of all the SDKs when you write a library in one SDK. This is also helpful when you want to bootstrap a new SDK. You don't have this daunting task of saying, okay, I have to look at the list of IOs that Java supports and the list of transforms and the list of analysis operations and everything that Java supports to try to get parity. You can say, well, as long as I can call those operations cross-language, my SDK is going to be very, very rich just right off the ground. So let's look a little bit how this works. So just as before, the user uses their SDK, say in this case a Python SDK, to build their pipeline. And at some point they say, I want to make an external transform. So this my transform here is actually defined in a different language. And so, but it has some parameters, here param equals value. And I just build it onto my pipeline just as before. With the pipe operator if you're doing Python. If it's Java, you do java.apply my other transform. And under the covers, what happens is it calls into the other SDK and has a language agnostic representation of what this transform should be, meaning it's kind of defining parameters. If I'm reading a text file, that's, say, the path to the text file. If I'm executing an SQL statement, maybe that's the statement itself and some schema information. And this external SDK offers a service and transforms it into a fully expanded graph. So a lot of the transforms, it's not just a single do fun, but it's kind of a whole mini pipeline and composite operation. And you can see here, one of the things that that's important is we want to have kind of idiomatic representations in the various languages of what these parameters are. So for instance, in Python, we'll just take keyword arguments or a dictionary to specify what the parameters are. And then when we call it in Java, we'll have this POJO that represents the same things. This makes it easy for someone to develop a pipeline, a transformation, such that they say, this is my configuration object, and now I can call it from Java, from any language that kind of supports key value pairs. So after it gets expanded in the external SDK, this kind of graph fragment gets shipped back to the client SDK and patched right into the graph. Now, the colors are a little hard to see here, but you can see, if you look closely, these are little green blobs representing the green SDK, and here's the little yellow blobs that are embedded in little pieces of the external SDK, because it's referencing possibly other operations, other code, other libraries that live over here. And then I continue my construction, building on those results as before. And now it's time to actually execute this pipeline. So what the runner does is the runner inspects the various nodes that I have and tells the workers what kind of execution environment it needs to operate on these user functions. And you can have any number of SDK environments for any number of workers. And this is how we get multiple languages all working together in the single pipeline. So this is a very powerful kind of extension of Beam, and I'm especially excited for it. So I mostly work on Python, with Python being able to use all the libraries that are already available in Java without having to duplicate all the libraries. Now, it should come with some caveats. One of the things that we're still working on is, if you're observant, we never mentioned the life cycle of this component here. So we're still working on, okay, how do you control that life cycle? Right now, what you do is you have to manually start it up, and then you can point to it. But this could be, for instance, could be hosted by a cloud service, or the SDK can have some information about how to start up this service. And the other thing we're working on is automatically doing some introspections where the SDK can query the server and say, okay, what transforms do you have available, and automatically generate nice stubs with good documentation and everything in this SDK's language for expansion. So there's still some rough edges to work out, but the basic idea works. So the other thing about the portability framework that we're working on is there's a lot of new features that are being developed solely on the portability framework. So splittable do fun is this idea of being able to take the power of sources and embed them in arbitrary points in your pipeline. So one of the most common requests we get is people want to take a pub substream of file names and then actually read those file names. But unfortunately, the current Beam read operation only can exist at the root of a pipeline. So splittable do fun allows you to build up operations where they act like sources, but they don't necessarily occur at the root of a pipeline. There's also work going on with Beam metrics, having more rich feature set of metrics. So for instance, system metrics, where you can query, say, if your pipeline is running a little bit slow, you can say, okay, what do fun took the most of my time? And right now you can gather these metrics on the portability API and say, okay, get a tree map of this, and you spent 25 minutes in this do fun aggregate over your whole pipeline. That's where you want to spend time optimizing your work. You can get also richer user counter types. So for instance, right now we basically have sum events where you can say I have C1 of them, C2 of them. We're exploring things like summing of doubles, distributions, histograms, quantiles, and that kind of thing on the new portability framework. And also new runners and SDKs are targeting this portability framework because it's a lot easier. So the Go SDK exclusively targets the portability framework, and the Samza runner as well is just built on top of this. So portability is really kind of the future of where things are going. The status of portability is fully implemented in the Python SDK, mostly implemented in Java. There's splittable do funs is kind of the one piece that's missing. And the Go SDK has nothing but the fun API. As far as runner supports, there's a universal local runner, which is a runner that can run any language pipeline. and that supports the full portability API. Flink kind of was the test driver for this, and so Flink implementation of the portability API is nearly complete. There's some pending PRs for stuff like metrics and splittable do fun, but it's kind of was the first big runner to support this completely. And that allows Flink, for instance, before Flink could not run a Python or a Go pipeline, and now Flink can. Dataflow has some support for this. It's guarded by an experimental flag. And there's ongoing work to hopefully make it the default mode. And as I mentioned, in Spark, there's someone who's implementing this right now. And the first pull request went in, and there's a bunch of pending pull requests to kind of make this happen. Built on top of the stuff that was done for Flink is sharing the libraries to do this for Spark as well. So that's the status of portability. So that went faster than I thought. So in summary, the portability framework allows us to finally fully realize the vision of the Beam of really being able to choose your SDK and choose your runner and have every combination work together, not just some subset where someone did a lot of work. It unlocks a lot of exciting features like hermetic worker containers, multi-language pipelines, and splittable do funds. And new SDKs and new runners are targeting the portability model kind of as their first target. So it's really the future of where Beam is going. So are there any questions?
So let's say I want to do a MapReduce mixing Java, Scala, and Python. So I want to do some MapReduce job with Python UDFs or something like that. How much overhead would I incur using portability as opposed to writing some own custom wrappers in Scala itself to convert Python types?
Yeah. Excuse me. So the question was like, how much work to mix these versus, if I understood right, writing a custom mapper that invokes the Python code?
But how much overhead, performance overhead also?
Yeah. So we've actually gone to a lot of work to try to minimize the performance overhead. So I have an extra slide here. So what we do is, one of the important things is if you go back and forth for every element, that induces a huge amount of performance overhead. And so what we actually do is we pipeline these elements into big bundles, and we send fused chunks over to the worker. And so we fuse as much as possible. And then we just send the results back. So it's actually quite efficient. And most of the time the data goes over this boundary here is just when it goes to another shuffle. So you're going to another machine anyway. It doesn't matter that you're doing this interprocess communication. But yeah, this was a lot of research went into trying to make this as fast as possible. And for a purely IO-bound pipeline, we're looking at about maybe a 5 to 10% overhead. And most pipelines are not purely IO-bound, so that's kind of upper bound. And that's also on the Dataflow framework where a lot of work went into optimizing it. And then we just stuck this thing in between. And so we think we can get it down to negligible. Yeah, that's really important because we're converting people over. We can't make it more expensive. Good question, thanks.
Will the native SDKs be deprecated once the portability framework is complete?
Yes, eventually. I think it depends a lot on kind of like duplicating the full feature set. So for instance, with Python, one of the advantages of Python being less mature is there's less to duplicate. But I think Python is going to be the first one we roll out where all Python is going to be over this fun API. Go, already you can't use it without the fun API. And then Java, I don't know what the time frame is, but we're hopefully going to migrate Java all over to the fun API. Deprecation timelines are really hard to pin a date on, but I would be happy if in a year we're basically completely ported over. Yeah.
What's the most popular combination you see in terms of languages and runners at the moment?
Yeah, the most popular combination in terms of languages and runners. Well, so Java only works well on, before portability, Java is the only one that works on all the runners. So that obviously is a very popular combination. We had a lot of demand for Python on Flink, which is one of the things that spurred this work. And I guess I have a lot of visibility, of course, into Dataflow because I work for Google, and we have Java as the most popular, and then Python follows that, I think just because the adoption rates are heavily dependent on how long something's been available. So, yeah.
Can you describe a little bit about what would be required in order to build a new language support? So let's say I want to start supporting JavaScript. Where would I start, and how long would it take? As a rough guide.
Yeah, good question. So last time I was in London last year, I actually gave a talk entitled "How to Build an SDK," which is where this diagram comes from. So essentially what it boils down to is you want to be able to support these 4 APIs. This is the control plane, which basically tells you, it sends over the descriptions of work and asks you to do the work and ask for progress. The data plane multiplexes the actual data itself. The state plane supports, Beam has the notion of stateful operations and timers, and also, for instance, your side inputs, your broadcast variables are over the state plane, and then there's this logging one. And so kind of the amount of work required to support a new language, the bulk of it is here. And then there's also a little bit of work to actually write the SDK. You have to write an API that allows you to describe a do fun, describe a type, wire them together into a graph and stuff like that. So yeah, I would like to see more SDKs, and this is kind of laying the groundwork for that. And there's a talk, if you look at the Beam London Summit, there's a talk, how to build your own SDK. So yeah, great question.
Do come.
Thank you, Rob. Great talk. What about the Scala? I mean, SIO. Is there any work to actually, because it maybe relies on Java, but is there any work for the portability as well?
So for Shio, it's actually you almost get it so Shio is, so there's SDKs and then there's DSLs, and kind of the difference between a DSL and an SDK is a DSL is built on top of another SDK. So in some sense, it kind of, if we go back to, I guess it was my first slide. Sorry about that. This right here. So it actually gets portability for free because it talks the Java SDK, and then the Java SDK goes through the portability framework. Yeah. So, and if you're in a JVM-based language, this is a reasonable approach. If, for instance, with Python, people experimented with doing Jython. People experimented with doing linking in the JVM and the C compiler together. That gets a lot sketchier because people don't choose Python because, some people like the syntax, but most people, they don't choose Python because they want the syntax. They choose Python because they want pandas, they want NumPy, they want SciPy. They want kind of the ecosystem, and that doesn't work if you're trying to do fake Python on top of a JVM. And similarly with Go and other languages, if you really want to bring in the ecosystem, then sitting on top of a non-native ecosystem doesn't work the same. So you really want to go this route. Yeah.
Yeah. So regarding the status of Python on Flink, like right now, can I start writing fully featured Flink apps using Python, using Apache Beam?
So I had trouble understanding. Is it you're asking is Python on Flink supported?
Yeah. So if I understand correctly, now Python on Flink is feature complete, or did I get the wrong impression?
It is nearly feature complete. So right now we don't get metrics back, which is fine if you don't want to read metrics back from, we have this API for querying metrics from the runner that isn't that commonly used, and that's not done yet. And then the I/O story. Right now, you kind of have to go through some hacks to get a native I/O to work, and we're in the process right now. I'm actually talking with some of the Flink developers and some of the people working on Apache Beam Flink to get SDFs into Flink. So Lyft is actually running some of their they're running a bunch of Python on Flink jobs right now in their production environments. So it is totally doable. We're running TFX, which is our machine learning pipelines on Flink on Python. So I'd say it is complete enough to use, but that doesn't mean that we're all the way done yet. But we're nearly done.
I see. Thank you.
Yes.
Anyone else? Okay, thank you very much, Robert. Please give Robert a round of applause. So that brings us to the end. I'm not sure if we can still... Yeah, we can still stick around for another drink, grab another beer, have some more pizza if it's still warm, and talk to each other. Thank you very much for coming.